All right, let's jump right into this explainer. Look, right now, the whole development world is going through a massive shift, specifically with GitHub Copilot moving from per request pricing straight into usage-based billing. Suddenly, every single interaction has a visible price tag attached to it. And yeah, that's got developers and organizations paying very close attention to their token consumption. But, instead of just sweating over the raw cost, we really need to reframe this entire conversation. Because everyone is panicking about token costs, right? But the actual question we need to be answering is whether we're making the absolute most out of the tokens we are spending. When we focus purely on making the field cheaper, we totally miss the point. We shouldn't just be asking how to blindly cut costs. No, we should be asking how to increase the value and the quality of every single agent output so that we naturally use fewer tokens to get the exact right result. So here is our roadmap for today. First, we're going to look at why we need to stop gambling with tokens. Then, why quality beats cost. After that, we'll take a peek inside the context window, go over some highly practical optimization levers, and wrap it all up with the top 5 developer tips. Starting right off with Section 1, Stop Gambling with Tokens. We literally have to fundamentally change how we view agent dispatching in our daily workflows. Because right now, let's be honest, a lot of us use agents like a giant slot machine. Imagine if NASA treated their rockets as incredibly cheap. They might just, fire 20 rockets roughly in the direction of the moon, just hoping one of them happens to land. And if none do, well, just fire 20 more. That is exactly how developers are treating AI agents when they give barely any context, rate a super lazy prompt, and just smash send. If we treat agents like cheap rockets fired blindly at a target, it becomes financially and technically totally unsustainable as we scale up to dispatching dozens or even hundreds of agents a day. The real solution here? Precision. We need to invest the right context into fewer, high-quality agents before we ever send them out. Which brings us perfectly to Section 2, Why Quality Beats Cost. This is where we look at why optimizing solely for cheap tokens is actually a massive trap. The mathematical reality of compounding errors is just staggering. Because large language models are non-deterministic text prediction machines, they carry an inherent error margin. Always. Let's say an agent operates at a seemingly solid 95% accuracy per step. Well, over a 50-step sequence, that success rate plummets down to a catastrophic 8%. Let me say that again, 8%. Even at a highly optimistic 99% accuracy per step, you're still dropping to 61% accuracy after 50 steps. Every single quality miss wastes tokens, requires bug fixes, demands more reviews, and forces additional prompt runs. To combat this compounding error, we have to lean hard into deterministic controls. Take the Copilot CLI team at GitHub, for example. They're shipping something like 500 pull requests a week. And to make sure their agents actually stay on track, an incredible 50% of their entire codebase is strictly dedicated to tests. Half the codebase. Why? Because a test acts as a hard guardrail. It's totally binary. It either fails or it passes. If an agent drifts down to a 50% accuracy rate after 10 steps, a failing test stops it dead in its tracks. It essentially prevents the agent from building a buggy change on top of another buggy change, which, would otherwise waste countless tokens and probably cause a huge incident. That failing test resets the accuracy right back to 99% by forcing the agent to correct itself on a stable, proven foundation. Moving right along to Section 3, Inside the Context Window. Let's pop the hood and look directly into the mechanics of this. Finding the perfect balance is literally the fundamental skill of context engineering. Remember, LLMs do not remember your past conversations like you or I do. They are completely stateless. Every single time you chat, the agent is resending the entirety of your past inputs and outputs on every single turn. So your token count isn't just growing, it's compounding. If you provide too much context, irrelevant information biases the model. Too little, the model starts hallucinating to fill in the blanks. What you are really aiming for is the Goldilocks context, providing as little context as possible, but exactly as much as required to prevent both hallucination and bias. To put those context sizes into perspective, the larger models today can handle absolutely massive inputs. We're talking up to 1 million tokens. For a quick mental model, 1 token is roughly 3/4 of a standard English word. So 1 million tokens, that is basically the entirety of the Lord of the Rings trilogy plus The Hobbit all dropped into one single prompt. It's wild. But hey, just because you have that massive capacity doesn't mean you should actually use it. Agents suffer from this phenomenon known as lost in the middle syndrome. They heavily favor instructions at the very beginning of a prompt and the most recent context at the very end. Everything in the middle, often ignored. Once you fill a context window past 50% capacity, severe recency bias kicks in. The model literally starts forgetting your original system instructions, goes totally rogue, and starts hallucinating code you never even asked for. That is exactly why you should try to keep windows under 60 to 70% capacity. Oh, and definitely use commands like clear liberally to prevent session bloat when you're switching between tasks.
Okay, Section 4, Practical Optimization Levers.
Now that we know the very real dangers of bloated context and low accuracy, let's look at the actionable levers you can pull right now. Your first major lever is model choice. A super common mistake is just defaulting to the biggest, smartest model for every tiny little task. But using a heavy reasoning model for simple implementation can actually backfire. If you give a heavy model a tight, detailed spec to just execute, it might actually pause, overthink it, second-guess your entire plan, and go completely off script. You absolutely have to match the model to the task. And choosing a smaller model for simple execution isn't just about speed or preventing the AI from overthinking. There is a staggering 24 times cost difference between a top-tier reasoning model and a lighter implementation model. 24 times. That is a massive lever for your token economics, especially when you're running dozens of agents simultaneously. Your second lever is phase splitting. A lot of the time, we ask an agent to research a problem, plan a solution, and implement the code all in one giant session. But doing that just drags all those irrelevant research files through every single conversational turn, which degrades quality and burns tokens. By splitting these tasks up and actually creating brand new, fresh context windows between researching, planning, and implementing, you bypass that recency bias entirely. It keeps the agent highly focused and super efficient. When you're configuring your custom agent markdown files or persistent instructions, keep them brief. And here's a pro tip. Write them yourself based on real agent behavior in your project. AI-generated instructions tend to be way too polite, super wordy, and highly imprecise. Output tokens are the most expensive, so a human-written instruction as simple as be concise, drop the niceties, only return code yields fantastic results and saves you real money. Now, for the power users out there orchestrating hundreds of asynchronous agents, you have even more levers. You really need to be careful with heavy model context protocols or MCPs. For instance, an MCP like Playwright is absolutely amazing for web front-end work, but if you leave it enabled for a simple CSS color change, it might take a costly, unnecessary screenshot and consume massive amounts of tokens. Utilizing custom agents specifically scoped for your workflows, like test-driven development, and using lean CLI tools instead of heavy MCPs will shave off huge amounts of wasted compute. Let's wrap up this explainer with Section 5, our top 5 developer tips. So to summarize everything into 5 concrete rules you can implement in your IDE right now. Choose the right model for the specific task. Provide crystal clear, precise prompts. Split your tasks to isolate context windows. Build deterministic guardrails like test and linters, and maintain concise, human-written agent instructions. If you do these 5 things, you will drastically increase the value of your outputs while naturally suppressing the tokens required to get there. Don't stuff your prompts with just-in-case context. Clear your context window when shifting tasks. It's all about that precision. Because ultimately, strong software architecture and rigorous testing are absolutely your best token optimizations. You really can't separate good engineering from good agent usage. Because at the end of the day, optimizing the token cost on a zero-value hallucination is just useless work. So before you fire off your next prompt, ask yourself, are you just trying to make your AI fuel cheaper? Or are you finally ready to engineer agents that actually hit their target?